Teslas and how they have self-driving cars, where they've got tons of data from a video standpoint, but then you can throw that car into any kind of situation and it learns on the fly, kind of, instead of having pre-programmed set of data. So it's, like you said, it's more, I guess, generative versus just straight kind of feedback and trying to learn by teaching it millions of different models or billions.
Yeah, it's a good point. I mean, I think there's so many probably different sets within that as well. I mean, you're looking at that where it would be machine learning because it's got to take all those pattern recognition and things like that and apply it to, the video feed that's coming in. But it has to have gone through that machine learning process of a car, a truck, a bicycle, and scenarios, beforehand. So it's maybe not, in my understanding at least, not generating the same as the transformer kind of models that are actually creating new. It's more analyzing again. So those are the basic definitions. But then we also look at the next area, which is the type of learning. So, looking at machine learning, you've got models that are typically trained for specific tasks. So that's things like classification of data or regression or clustering. Some examples of like house price production or supervised learning, where a machine learning model can be sort of trained to predict the price of houses based on features. So it looks at like, okay, what's the location? What's the size? What's the number of bedrooms? Or something like customer segmentation, where it's unsupervised learning, where retailers can use unsupervised learning to cluster customers based on their purchasing habits, or kind of enabling things like personalized marketing.
Yeah, it's a very narrow objective.
Yes, that's it.
That does, for a very specific task, yeah.
And then while that can be supervised and unsupervised, you look at the very much unsupervised nature of GPT models, where it's that unsupervised learning during, again, the pre-training phase. So, and that with the goal of really learning to predict the next word in large amounts of text.
The great thing about the GPT model is that it's almost, because it's so general, it can be used for a wide application of things. It's not just that narrow, specific pinpoint task
Correct.
that, standard machine learning models have been made for. But what's also great about fine-tuning is obviously the process of taking an existing model and then adding more specific data and working with it in a different way, or sort of fine-tuning it to a more specific task. You can take something like a GPT model. You can obviously just prompt it in certain ways to get it to what you want to do, but if you really want to go to the next level, you can fine-tune it and provide it even more specific and public information that doesn't really know, like your own company information or your own personal information, to get it to specialize maybe in your company's knowledge or your company's domain knowledge as an option. There's loads of different options around that, but yeah, that's what's great about them too.
I assume there's a difference too between video or image processing versus video generation, like Midjourney and all that. That's more GPT versus
that's more machine learning, I would almost imagine, right, Bryn? If you think about it,
well,
like that,
I would say it's a mix.
Creating video, you'd think it's a mix.
Well, okay. Not a mix. Well, it's imagine that it has to. So you look at some of the transformer, the video kind of transforming technology. That doesn't have enough training data on things like hands or walking cycles. So it's very much about the pre-training data. So it's doing a transformer. And I suppose it's more GPT in terms of it needs that pre-training and then it generates. So it is flexible. Machine learning models are task specific, meaning that their architecture and training are designed to solve a particular problem. That output depends on the specific application. So whether it's like spam email detection or disease diagnosis. And again, getting back to GPT, as you were saying, Joe, completely versatile in terms of their output. And I think that's where we can see things like the video generators to be similarly versatile in that they can generate a lot of different outputs based on all that pre-training data.
Yes, generating more like a new thing, a new output versus just analyzing what's there.
Yeah, exactly.
Looking at Sora, that does seem to be based on a machine learning based system. It's not really built off an existing GPT model. It's not fine-tuned.
Oh, interesting.
It specifically uses a diffusion model combined with transformer architectures.
Well, the transformer architecture would be very much GPT.
Yeah, GPT models are made very similar. Yeah, but it's not like it's taken from a GPT-4 model and fine-tuned, or it doesn't rely on a GPT model to operate. It's definitely its own thing, using very similar methods of trading it.